So now we're going to go through a quick example of an if-else if statement or multi-selection. I just want to point out a few things and review a few things. First of all, we're working in a console, and the main reason we're working in a console is because it's just simpler to do output, because we don't require any conversions or anything like that. The code wise is exactly the same. You only need static at 2 points. You need static when you have global variables, and you need static when you have a new subprogram. We're not going to be using either of those in this case, so we're not going to have to worry about the keyword static. We're going to do everything right inside the main. So that's pretty much it there. Again, where does this code go? Well, again, code can't just be sitting out in the middle of nowhere. It must be in some form of subprogram. That subprogram could be the main, it could be a subprogram you create, or it could be the event of some button or text box or something like that, depending on what you want to do. But it must be in some form of subprogram. So we're going to create a fairly simple example here, and I'm going to start off by creating a variable called a numerator, which is going to be an int numerator. As we know, a numerator is the top of a fraction, or the top of a division. I'm just going to give it the value 1. Very simple. The next variable I'm going to create is something called a denominator, int denominator. Now the denominator, as you know, is the bottom of a fraction, or the bottom of a division. Now I'm not actually going to give it a starting value, because we're going to get that information from the user. So down here, we're going to ask the user for the information, console.writeLine. Please enter the denominator. And then we, of course, we have to read that in, and we have to convert it because denominator is an integer. So denominator is equal to convert.toInt 32 of console.readLine. Something that you should be an expert on by now. And now we're actually going to do the multi-selection. This is where we're going to make our choice. And this program's purpose is going to be very simple. All it's going to do is it's going to validate the denominator that the user enters in. So it's going to tell the user whether it is possible to do the division, or whether the result of the division will be positive or negative. We know that based on the denominator, since our numerator is a value of 1. If the denominator is negative, the result's going to be negative. If the denominator is positive, the result's going to be positive. If the denominator is 0, the division is not possible because we can't divide by 0. So we're going to start off with a basic if statement. If denominator, lowercase d, is equal to 0. So remember, we use the double equal sign to compare an equality, exactly equal to something. So I can say, well, again, you'll see how I create those brackets immediately so I don't accidentally forget to do one of them. And when I click enter on there, it automatically indents it for me, so I know I'm doing something right. And all we got to do is output a simple statement that tells the user that the number is not divisible. Number is not divisible. And now I'm going to do some else if code in here. So now we have multiple choices. Else if denominator is greater than 0. Well, if it's greater than 0, that means that the result must be a positive number. So I am just going to copy and paste this stuff just to shorten down the demo a little bit. Oops. And this time I'm not going to say the number is not divisible. I'm going to say the number is greater than 0. So the number is positive. And I'm just going to duplicate this because our next else if code is going to be the exact same thing, only this time, instead of being greater than 0, we're going to check it for less than 0. And if it's less than 0, that means the entire statement itself is negative. So now we've just done some multi-selection. And just to be consistent with the previous example, I'm going to do a final statement that says all done. You don't normally need this in your code. This is just for demonstration purposes, of course. And if we run our program, hopefully we have no errors. We have one, of course. Oh, I forgot my .writeLine, which I'm sure a lot of you caught immediately. We run our program now, and we have no errors. Please enter the denominator. Let's put 4. We get the number is positive, and it's all done. So let's try one more time. Let's put -3. Enter the number is negative. All done. And let's try a value of 0. We put in a value of 0, and we see the number is not divisible. So what we're using this if statement for is essentially We could use this as error handling. Let's say, for example, you ask the user for a number, and you plan on using that number for a calculation, but 0 is an invalid number. You could enforce this by checking to see whether the user entered a valid number or not. If they didn't, you say, please enter another one, or try again, or tell them that it was an error, or something along those lines. So I'm going to go through one more example that's a little bit more practical, and it's going to demonstrate some other things involved here. But before I do that, I wanted to talk about how we properly document something like this. Where do the blocks go? Well, you can see I've already created some blocks. First of all, we have our block up here. Very basic block here, which is the variables to represent the fraction. So variables to store the fraction operands. Down here, we're asking the user for the denominator. So retrieve the denominator of the fraction from the user. Now we get into the part that's new. So first off, the if statement itself as a whole, so the whole thing here, from here to here, is considered one if-else if statement. It is a code block in itself, so this code block itself is going to require a comment. Each block inside, or each piece inside of each if statement itself is its own block. So that's a block. That's a block. That's a block. And this is not really attached to it, so that's its own block as well. So every one of these chunks is essentially going to need some description of what's happening as a result of their piece of the puzzle. So for example, this comment is about the whole thing. So this one is verify the denominator entered by the user. So this encompasses the entire if statement. Now here I could say verify the user did not enter, or sorry, verify if the user entered 0. And now you could say verify whether the denominator is positive, so on and so forth. Verify if the denominator is positive. Now you notice that this comment is kind of about the if statement itself, not necessarily the code here. We don't want to put this comment anywhere but inside, because otherwise we're not sure where exactly it applies to it. So we put it directly inside. Sometimes you might have multiple blocks inside of each if statement, or each piece of the if statement. So each block still needs its own comment, just the same as before. And you'll see that we have a comment there, and we would also have a comment here as well. I'm not going to go into any more detail on that, but I am going to continue on with the next example. So now you know where to document properly for an if statement. So the next example is, again, slightly more practical. So we're going to say create a variable. It's going to call it num. And it's still a demonstration, so there are certain pieces that we're going to ignore and just continue on with. So I'm going to ask the user for this value. Console.writeLine, please enter a number. Very simple. We don't care what that number is, we're just going to ask them for the number. And I'm going to have to read it in. Converter to int 32, console.readLine. Oops. So now we've read in the data. Now we're going to do our if-else if statement. Now watch how this is set up. I'm going to say, okay, well, if num is less than 10, then we're going to say, well, then that means that the number they entered is a single digit. Say number is a single digit. I'm just going to copy this line because we're going to need it in a second. Next check I'm going to do is an else if statement. Oh, I accidentally have an extra bracket there. Is the else if statement. So I'm going to say else if num is less than 100. And then we're going to do the exact same thing, but this time, instead of a single digit, it's a double digit. Since the number is less than 100, that means it's at most 99. So an extra bracket. And then finally, I'm going to say else if num is less than 1000. And we're going to say, okay, this time it's a triple digit. So let's actually try it out. We run our program. Let's put in the value 6. We get that it's a single digit. Let's run it again. Let's put in the value 12. We get it's a double digit. Now, what I wanted to show you here is that there's something very special about multi-selection, and that thing is that order is important. Now, I told you before that only ever one of these pieces of code will ever be executed, because as soon as a valid or a true test expression is found, the code is executed and the rest of the code of the if-else if statement is then skipped. So how do we emphasize this? Well, let's try this. Let's say I moved this code right here. Let's move this one up to the top, right here. And we moved this one down to the bottom. Put in some white space here. Now this is going to have to be an else if now. And the top one's going to have to be an if statement in order to keep our syntax correct. And now let's enter that value of 6. We entered 6. And this time we get the number as a triple digit. Well, let's take a look at that code. It's saying, okay, we read in the data and we tested it. We say, well, is num less than 1000? Yeah, it is. Num is 6. So it's going to go in here. It's going to say, well, you're a triple digit. And as soon as it's done that, it's going to skip the rest of the code and continue on with the program. So by not paying attention to the ordering of things, we've essentially set up a system that may be syntactically correct. So the syntax is correct, but the logic is incorrect. So we're going to get unexpected and poor results. So I'm just going to fix this, and just more simply, I'm just going to put those numbers back in and change this to a single triple digit. Change this one up to a single, and this to a 10. So what you've seen here is that the order is actually important, and that we figure that out just by changing around things. The next thing I wanted to show you is that we can actually create ranges of data. So for example, I might say, okay, well, if the number is less than 10, then output it's a single digit. I can also say, else if num is less than 100, but we're going to stretch that out and we're going to put this piece right here. If num is greater than or equal to 10 and num is less than 100. So essentially what I've said is, as long as the number is greater than or equal to 10 and the num is less than 100. Remember, for the and to be true, that means both pieces must be true. You'll notice that they're completely distinct if statements, and they're just attached together with that and operator. I can't say something like this: if num is greater than or equal to 10 and less than 100. That is not valid. It needs to be two completely distinct if statements that are then kind of stuck together with this and statement. So they each are evaluated all on their own. Now remember, the and statement says all the elements must be true for the result to be true. And we could do the exact same thing down here. We could say if num is greater than or equal to 100 and num is less than 1000. So if we run our program and I put the value 12, we should get that it's a double digit, which we do. So that's how we can create, both using compound statements to create a range of data.